Welcome to lesson 20 of this Arduino C++ course, and today we're going to build on lesson 19. Lesson 19 was about setting up the L298 motor driver, and today we're going to turn it into a bit of a project by adding some joystick control. So at the end of the last lesson, we'd learned to send the motors in opposite directions, and then using PWM, pulse width modulation, we could change the speed. So we have one motor going sort of flat out and one going at about half speed. Now, one of the problems that you often have with tutorials is, of course, it shows you how to control the individual component, but not how to make it interact with something else. So today we're going to use the joystick down here, just one of these cheap ones. You can see I've got another one here. It's basically two potentiometers, and obviously the little thing sticks on the top, and you have a basic joystick. Now, one thing just to be aware of, just looking at this joystick, if you look at the connections, there is a ground, there is a 5-volt, we've got, VRX, VRL, and then SW. SW is for a switch, because there is actually a push button on these things that you can use alongside the movement. So the goal of today's lesson is to have some form of control of these motors. Let's just move that one out of the way. So if I move this joystick now, if I move it forwards, you can see both motors turning in the same direction, obviously bringing it backwards in the opposite direction. I'm just going to press the button, and you should be able to see on the Arduino, let's just get my little pointy stick, we have the built-in LED that I can turn on or off as if it was some vehicle lights. Now, what I'm going to do is, if I move this in the forward direction, if you watch the motors, as I move it to the side, you will see that the one motor slows down while the other continues at its original speed. And obviously we can go back and do this in the reverse direction as well. The idea of this is obviously to be able to provide some form of skid type steering. So that's the project we're going to be working on today. Now, as always, there is a resource page on the Digital Town website, and the link will be below the video. So let's have a quick look at that to see the circuit diagram. So the link brings you out on the lessons page. Just scroll down until you get to lesson 20, long way down now. And obviously we can click on the image for a large version of the circuit diagram, and you can download the sketches for today's lesson. Right, let's click on the circuit diagram and have a look what's going on. So in the last lesson, lesson 19, we connected up the motors. We had the enable pins connected to pins 3 and 11 on the Arduino, so that we could send a PWM signal that would control the speed of the motors, and then we had the direction control pins connected to pins 10 to 7. None of that changes for this lesson. All I've added is this joystick here. So you've got ground to ground. We've got 5 volts to the 5-volt. Now, one thing to be aware of, the motor power supply, if you remember, is not coming from the Arduino, and you do not connect it to anything. The reason is that the motor power supply, in my case, these motors happen to be 5 volts, but these motors, this driver board, it can take 25, 30 volts. So these could be 12-volt motors. So obviously connecting this 5-volt, this 12 volts, which it would then be, to my joystick is going to produce smoke from the joystick. So power this from the Arduino. You then have the next 2 pins, which are going to connect to A0 and A1. These are the potentiometers within the joystick. depending on the orientation, as you'll see, I've got mine on a sideways orientation because that's how it fits on my bench. Obviously you may have it the other way around, so that will depend how we use these pins. And then finally SW is connected to pin 2 because that's just going to be a digital connection. Right, we've done that. So once you've got your wiring done, the next bit we have to do is check the wiring is correct. So the first sketch we're going to work on today is actually called Joy Motor Driver 4, and that's because it was based on Motor Driver 4 from the last lesson. So in the last lesson we got everything working nicely. So this lesson, all that we are adding are 2 pins. We're going to add joy button, which is 2, that stands for the joystick button, and then we've got the LED pin, which is 13. Now I know that I could just use the variable sort of built in. The reason I've not done that is if you were going to use this for an external LED, obviously you would change the pin to the pin that you would require. But also I don't tend to use the built-in because that pin changes from between different boards. I use a lot of ESP32 boards. Some of them don't have the built-in LEDs. On the one I use most of the time, it's on pin 2. So I actually like to use the pin number so that I know clearly which pin I am working with. Now, a bit of an oddity on the circuit. We're connecting pin 2 to the switch. When we look at our sketch, you will notice that the pin mode is unusual. It says instead of just having input, usually I would use a pull down resistor, an external sort of 4.5K to 10K resistor, but because of the way the joystick is set up, it makes it a little bit more of a hassle to set that in the circuit. So we're going to use the pull up resistor, and this is a resistor that is built into the Arduino. Now the difference between using a pull up and a pull down resistor is if we use a pull down resistor, when we do a digital read, you get a value of 0. When you press the button, you get a 1. With a pull up resistor, you will get a value of 1, and when you press the button, you will get a 0. Finally, obviously, I've just set the pin mode for the LED pin, although it's not going to be used in this first sketch. I've then left the motors running at a speed, and then we're going to do an analog read on pin A0, analog read on pin A1, and we're also going to do a digital read on the joystick button, and we're just going to serial print that out. So let's get that running. So the sketch is up and running. You can see the 2 motors are just spinning away, and if you look on the serial monitor, if I move the joystick forwards, you can see the value goes down to 0. Pull it all the way back and it goes to 1023. Over to one side, 0, over to the other side, 1023, and obviously I can do a combination. And then the final column where the 1 is, that's the button. Press the button down and we get a 0. So at that point I can now see that everything is working. But one thing I do want you to just make a note of, if I move the joystick again, full movement is from 0 to 1023. I've now let go of the joystick. I'm not going to touch it at all. And if we look at this column here, we see a value of 512, 511. Well, if we think of the value of 1023, divide it by 2, and guess what? That's where we're looking at for a value. You'll notice this one varies between 496 and 497. So this little joystick here does not sort of center correctly. Now this isn't a problem because we can deal with this in code, and I'm not going to criticize the joystick because they probably cost about 25 pence to manufacture. you get what you pay for. But it's good enough for the lessons today. But it's worth putting these values down on a piece of paper, because we're going to use these values in our code later on. Now, I know some people wonder why I keep doing these sketches at the beginning just to check the circuits. Of all the emails I get to do with problems with the different sketches, I would say that 85% of them come down to a wiring problem. So that is why I do these sketches. I do them for myself when I do my own projects. I always check the connections first, because otherwise you're going to start digging through your code trying to find an error, and the error is something isn't plugged into the breadboard, or you've just put something in the wrong connector on the Arduino. We've all done it, but that's why this basic circuit check is so important at the beginning. So now we've tested that our connections are correct, we can now safely move forward with starting to build some code. And this sketch is just going to deal with using the joystick to provide a forwards and backwards movement. So we're going to build the direction control in a sort of a set of stages. Now, you remember I asked you to write down those values. I have got my values here for the forwards and backwards on my joystick. Now, mine was giving a reading of about 496. Now, if I bring back the image of the joystick for a moment, if I want to move this, when I bring it back to the center, it's quite useful if in the sort of the center position, it doesn't have to be bang on center for the, if you like, the motor to stop. We want to allow a little bit of error. Now, my center position was about 496, so I'm going to use two values, 493 and 500. One is the minimum reverse and one is the minimum forward. Now, I have worked out those by, if you like, when I was pushing it forwards, I was going up to sort of 1023, bringing it back was bringing it to 0. So when I'm in this direction, I want 0 to 493 to record movement. Then that center patch, 493 to 500, I want it to do nothing. Then going from 500 up to 1023, we're then going to produce forward movement. So this sketch is not going to do anything to do with the speed of the motors. It's just going to use the joystick to control the direction. Now, what I've done is created some variables, because in the last lesson, we had our motor controls and we could send a value of 1, which was forward, 2, which was reverse, and the default any other value was a stop. Now, just sending numbers over, it can get difficult to remember which number is which. So I've created some variables. Now they are a constant integer. That means they are, if you like, write protected. They can't be changed. And I've got these as the 1 as forward, 2 as reverse, and obviously 0 as stop. One other thing I should mention here, these are not variables. These are called definitions, and they are a little bit different to a variable. Now, I'll show you why I've had to use definitions later on in one of the later sketches. But the interesting thing about a variable, obviously it stores that information in the memory of the Arduino somewhere. So somewhere in the Arduino is a variable called motor forward that has a value of 1. When we make a definition, what happens is anywhere in the sketch where I write min rev, when the compiler compiles the code, it does a search and replace, and it will put to the value 493. So this 493 is not stored in memory anywhere. It's not a variable in a normal sense. I cannot alter that value because it's literally a search and replace in the code. Right, coming down to the setup, everything is as before, and all I've done for the motors is just set the speed at 150 for both of them. Notice I haven't set a direction. We're going to do that with the joystick. So at the moment we're just going to send a constant speed to the motors. So coming down to the main loop, I have created a variable, an integer raw speed value, and this is going to get the value from what I'm going to call the speed pin. Now on my board, the way I've orientated my joystick, the speed pin is connected to A1, the direction pin is connected to A0. Now in your circuit, if you like got the joystick sort of round 90 degrees, then you may need to change that over. So feel free to change the code to suit your methods, and obviously change these as well to suit your joystick. Right, coming down to the loop again, I'm still going to serial print out the direction pin, what's now called the speed pin, and the joystick, so that I can see all the information is going by. And then what I've done is I have set up a switch statement. Now I have covered the switch statement in a previous lesson. I think it is lesson 6. And the switch statement, unlike if you have an if statement where you sort of have an if or an if else, if you've got lots of different ifs, it can get a sort of what I call a nested if. It can get a little bit messy. So a switch statement allows you to go through a number of options. Now normally you would see the case and it would read case 0. So if the value was 0, it would do this code. If this value was 1023, it would do the next bit of code. But you'll notice here I have a 0, a space, 3 dots, and then min rev. Now, do you remember what I said about this definition here? When the compiler runs, that min rev is going to be replaced by the value 493, and min forward is going to be replaced by 500. So what this is now saying is it is saying if the value that's coming off our analog pin is between 0 and 493, then we're going to put both motors into reverse. We're not worried about the speed because our speed has already been set in the setup. If, however, the value, and you can see the definition value here, is between 500 and 1023, then we're going to put both motors into a forward configuration. And for that, all we're doing is passing this variable. Motor forward has a value of 1, motor rev has a value of 2. And then if the value is, if you like, the default value, it's not within that range, then it means we're right in that center part of the joystick between min rev and min forward. So it's got a value of between 493 and 500. In that case, we're going to send the command to both motors to stop. So all this sketch is going to do is deal with the setting up of the motor driver, should it be sending a forward command, a reverse command, or a stop command. So let's get that uploaded. So as you can see, both motors are stationary, and if you look on the serial monitor, you will see that we have the command to stop both motors being sent, and the joystick is 512, 496 and 1. Now if I move the joystick sideways, the value actually goes to 0, and going the other way it goes to 1023, but it doesn't make any difference to the, if you like, the speed of the motors, because we are only dealing with forwards and backwards. So now if I push it in a forwards position, I'm going to push it right forwards to 0. In this situation for me, that is reverse. Obviously the motors are moving at a fixed speed. If I move this anywhere in the reverse area, the motors continue to move at that fixed speed. Bring it to the center, they stop. Bring it back the other way, and I get my forwards direction. So now going back to our main loop, we can see that just by using this switch statement that is now covering a range of values, we are now able to use the joystick to control whether the motors are going forwards, reverse, or in the stop position. Now that is, if you like, stage 1. What we're going to do now in Motor Driver 6 is we're going to add in the speed control. So here we are at Motor Driver 6. Now, as always, the reason I do these sketches in stages is if you try to write all of this in one go, when you start to get problems in your code, you don't know whether it's, if you like, your forwards, backwards controls that are going wrong and your speed controls are going wrong. If you know you've conquered one part of the code, then you can set up ready for the next section. Now, for this next section, we are going to need 2 new variables. We are going to need motor A speed and motor B speed. Now, at the moment, as the joystick moves backwards and forwards, we will be sending the same speed to both motors, but we're preparing for the fact that eventually the motors will be running at different speeds, hence the reason for creating the 2 variables. Now, moving down to the loop, because I know that various things are now working, I have commented out the readings to the serial monitor, if you like, from the joystick. Also, in the functions that control the motors, motor A control and motor B control, you'll notice that I've commented out the serial print statements there. It's just that I wanted to put some other serial print statements in, and if you've got tons of stuff flying past the in the serial monitor, it just becomes impossible to read. Because we've done this sketch in stages, we already know that this is working correctly, and we already know that this is now working correctly, hence the reason we don't need to read that data anymore. Right, let's take a look at how we are going to change this. Now, I thought I'd try and do this by drawing a diagram. So at the moment, when on my setup, when the joystick is pushed in the one direction, I get to a value of 0, and right at the other extreme, I get a value of 1023. In the center, I have that region between 493 and 500, and for that, that's my stop position. 0 to 493 is the reverse, the center section is stop, and then I've got the forward. Now, that's easy, if you like, from a direction point of view, but when we come to the PWM speed, it gets a little bit weird, as you can see on the left. So for joystick value 0, I want a speed of 255, and as this value increases, I want the PWM speed to decrease. Then in this center section, it really doesn't matter what the PWM speed is, because the motor is set to stop. So the motor driver won't send anything to the motors anyway. But then when we move to the forward position, I then want the opposite, going from 0 to 255. So it's not a simple case of going, well, we'll start at 0 and we'll end at 255. We actually have to go 255 to 0. So these are the, if you like, the speed steps, the PWM speeds. 0 is stopped, 255 is as much as the power as the unit can deliver, and then going in the opposite direction, we're going from 0 to 255. Now, the reason I've shown you the diagram is just to try and give you a visual before we look at the code itself. So looking at the main loop, because that is the area with the changes that have been made, we had our switch statement that sets the directions, just as we've seen in our diagram. Now I'm going to add the code in that will, if you like, deal with the PWM speed. So let's get into that. So to set the speed, if you like, the PWM speed, we're going to use the map function. Now, I covered the map function in lesson 6, but let's have a quick look in the reference. So in the language reference, if we go to map, the parameters of map, it takes a value, a from low, a from high, a to low, and a to high. So it has a range of numbers and then a second range of numbers, and it maps the one set of numbers onto the other. So if this was 0 to 100 and this was 0 to 1000, if this value was 10, then obviously 10, it would, if you like, translate that from the one range of numbers into the other range of numbers. Now, going to the code, it can all look a little bit confusing at first. So we've got the value, if you like, our raw speed value. What I've done is I've had to do this twice. In the default, in the stop position, we're just going to set the motor speed to 0. We don't need to work that out. It's always going to be 0. So not only are we going to turn the motorboard driver off, we're also going to set the PWM speed to 0. When we're in the reverse state, then we're dealing with values between 0 and min rev in my version. So that is between 0 and 493. So we are going to map the value of 0 to 493 onto some values of 255 to 0. Now this might sound weird. So if I set a value of 10 between 0 and is it 493, it's going to work out what that value would be in a range of numbers between 255 and 0. That's what the map function does, and again, that's been covered in lesson 6, so I'm not going to elaborate on it too much. We're going to do that for motor A. We're then going to do it for motor B. Now, obviously, if we are in the forward direction, then instead of it being between mapped over min rev to 255, we're now going to put the raw speed value of 1023 to min forwards. Remember on the diagram that this is now, if you like, that bottom block, and once again we're going to map that between a value of 255 and 0. So by mapping the value between this 500 and the 1023, it's going to find the equivalent value of between 0 and 255, which will be the speed that is sent to the motors. Now, once we have that PWM speed, all it is going to do is I'm going to serial print out the speed, the raw speed value, motor A speed and motor B speed. At the moment, those are both going to be the same because we're not using the side-to-side movement of the joystick. And then I'm going to send that analog write, send the new PWM signal to motor A or motor B. So now as I move the controls, this value here is the analog read from the joystick. I then have the two motor speeds, which at the moment will be identical. So if I move this fully to my reverse position, my joystick is now sending an analog read value of 0. And obviously I'm pushing it all the way back, so I want it flat out in reverse, which would be 255. As I now start to bring the joystick backwards, you can see the values start to drop down, and you can see that the motors are slowing down. Finally, we get to that center section where both motors are 0. Now, as I start to go in the reverse direction, if I pull it all the way, 1023 is going to give a speed of 255. As I move it now back towards the center, he says, hopefully, there we go. As you can see, the values start to drop. Not always so easy with these cheaper joysticks. To be honest, that they are not the most accurate in the way that they read, but they're fine for the learning experience. So now looking at our diagram, we've not only got the direction control sorted, but we now have the speeds. Now the next issue, of course, is that at the moment I'm sending the same speed to both motors. As we move the joystick side to side, we now need to be able to, if you like, change one of the motors so that it actually starts to slow down and we get our sort of skid steer method of changing direction. So here we are in Sketch Joy Motor Driver 7. This one we're going to sort of finish our direction control. When it comes to the setup, the change that I have made is I have now added in definitions for the left and the right. Now, the reason that I'm using definitions is that in the switch statement, this cannot be a variable here. So it needs to be a sort of a search and replace, a fixed definition. So as we come down through the code, the if you like, the setup is the same. What I have done is moved all of the code that I've written so far for motor control. I have moved it into a separate function. Now the reason for this is if I was building this as a car control project, I wouldn't leave all of this in the main loop because it gets messy. It's much easier just to, as you finish the code, set it up in a separate function. So every time the loop runs, it's going to call this function motor control, and you're now going to see the code that we've seen before. The difference is that I've added a few more variables. We've had raw speed value. Now we've got raw direction value, which is going to be the analog read of the side-to-side movement of the joystick. And then I've got motor A adjust and motor B adjust. And this is going to be the amount that I adjust the speed by of the motor depending on the direction control that I'm inputting. So we're going to start off with exactly the same switch statement as we did before. So we're going to do a switch on the raw speed value just as before, and at the end of it we're going to come out with a speed for motor A and for motor B as we've mapped it before, as if both of them are doing exactly the same speed. So they're both going in the same direction at the same speed. Then what we're going to do is use the side-to-side motion to work out the values for the motor A adjust and the motor B adjust. And this is actually very simple. And it's just the map statement again. I've got my minimum left and my minimum right. That's to get either side of that dead spot in the middle of the joystick. And we're going to do a motor adjust, a map, and we're going to take the raw direction, the minimum left, and then to 1023, the minimum right to 0. So very similar to the diagram that we had except this time, of course, instead of it being reverse and forwards, it's going to be left and right, and a center section that has, you know, straight ahead. But unlike the previous map functions, there's one odd thing in that we cannot put the value 0 to 255 in here, and that is because the motor may not be spinning at 255. So if we can imagine, if the speed is only 70 and I try to map against 0 to 255, I could finish up with an adjustment value that would be outside of the 0 to 255 range. It would actually be possible to finish up with a minus value, which is not good, because it says, you know, you've got to send a value between 0 and 255. So that is why we had to work out the initial motor speed first. So we've got these motor speeds as if we're moving that joystick backwards and forwards, and then the side to side we're going to do a map against the maximum motor speed that the motor is currently running at. And then it's very, very simple bit of maths. The original speed that we got from our speed control, we're going to subtract from that the adjustment value, and that will give us whatever value we should be sending to the motor. Then I'm going to serial print that out as before. So let's look at that in action. So this time down on the serial monitor, you've got motor A speed and then motor B speed. So as I move the joystick, you'll be able to see the motors, the values changing. So we're going to go forwards. Both of them are going flat out. I'm now going to move the joystick over to one side, and you can see that motor A speed is slowing down. And by just playing with it, so I'm trying to watch the screen and the motors at the same time, you can see I can control speed. There we go. Sorry, I've knocked a wire. There we go. And as you can see, it's now possible to have the motors running at completely different speeds. I can come off the flat out. There we go. So you can see we can have everything moving at different speeds and in different directions. Takes a bit of concentrating on to do that. So at this point, we have succeeded in having our direction control, speed control, and direction control by using a skid steer method. However, there is one item that we set up that we haven't sorted out yet. So let's have a look at that one. So going back to our circuit diagram, obviously we're reading the two analog pins to drive the speeds of the motors. But the one thing we haven't covered yet is pin 2, which is the push button, which is just going to turn on the LED. So the final sketch, Joy Motor Driver 8. The big change for this sketch is we're going to have that button working, and for that we're going to need a debounce. So for those of you who've been watching these series, current millis is back. I do not use delay. We need to use current millis, because if you use delay, if you put a delay in your code and we go down to the main loop, where are we? There's our motor control function. If we had a delay in here, then the motor control function is not going to be read until the delay has completed. That means you could turn on your LED or do whatever, and you won't be able to steer your vehicle because it's waiting for the delay to finish before it will do the motor control and its analog reads. So coming back up to the variables, we've got current millis that's going to keep the track of the board time, button millis, which is going to be our timer for the button debounce. I have set the debounce with a value of 0.4 of a second, 400 milliseconds. The reason is the button is a little bit awkward. Normally on a button I'd have the value between sort of 250 and maybe 350 depending how quick my fingers are, but for this one I've set it slightly higher because the button can be a bit awkward while you're trying to drive at the same time, if that makes sense. We then have another variable, just a byte, that's going to hold a variable LED state, and that's going to store whether the LED is on or off. Now this code was all covered back in lesson 5, so I'm not going to go into it in great detail. And this is the debounce code. So we're going to take the current time of the board in milliseconds. If the current time in milliseconds minus the button milliseconds is greater and equal to the button timer interval, then we're going to read to see if the button is being pressed. We're not going if the button is being pressed, and notice this time it's if the value is smaller than 1 because it is a pull-up resistor. If it is, we're going to reset the timer, and if the LED state is smaller than 1, we're going to set it to 1. If the LED state is 1, we're going to set it to 0. Once we've done that, we're going to change the LED state to whatever the output is of this if statement. So the way this works is press the button once, you'll turn the LED on, press it again, and you will turn the LED off. Now the nice thing about this, obviously I can press the button and turn the LED on, press the button again, turn it off. But because this is non-blocking sort of state machine type code, I can be dealing with the motors while turning the LED on and off, and nothing is going to block anything else. So that's basically it for today's lesson. You've now learned how to, if you like, make a skid steer control car. You could add some headlights on if you wished, and you can do that all from one of these cheap little joysticks. So I hope that's been useful to you, and it's useful for your other projects. Obviously I've used a joystick, but by adapting the code you could use buttons instead. You could use an infrared controller to send the commands over if you want. The important part of today's lesson was to see how you can control the speed and direction of a vehicle, if you like, by just manipulating the two motors' speed and direction control. So again, hope that's been useful to you, and if it is, please click the like and subscribe because it does help the channel, and I'll see you in the next video. Bye for now.